Hopefully this is working. Let me flip it for a sec. And today, this video is going to be about 7.4, which is solving log equations. And what I want to emphasize first is two things, really. Number one, I can't even spell the word remember. Remember the foundational basic relationship of a log is that if we are asked to do log base 2 of 8, the question is what exponent turns or gets 2 to 8? And the answer in this case is 3, right? 2 to the power of 3 is 8. That's not new. That's the basic relationship of a log. We can use this to answer some of the trickier ones that we have been presented with. For example, log base 9 of 3 root 3. This will sort of answer, we'll begin to discuss logarithmic equations and thinking about them. 9 to the power of what is 3 root 3? Well, we definitely can't see that off the top of our heads like we did before. But I'm going to say, I don't know what it is, but whatever it is, it's x. And the way that a log works would be 9 to the power of x equals 3 root 3. So again, this is a refresher. Now we've turned it in. It's the harder ones from the previous lesson, but now we've turned it in to being 3 squared to the x. And this is 3 to the 1 times 3 to the 1 half. We're trying to get everything in terms of 3, and we're also trying to get only one 3 with one exponent on each side. On the left, we can apply the rule of exponent to an exponent means multiply them. So that's 3 to the 2x. And then here, exponents, like the 3's being multiplied means add the exponents. So 1.5 or 3 halves. Then we can cancel out the big 3's and get 2x equals 3 halves. And then when we divide both sides by 2, we get x equals 3/4. So the answer to this log is then 3/4. 9 to the power of 3/4 is 3 root 3. So we can always reorder, and I do recommend it. This is probably something that is easier than seeing this log relationship off the top of our heads. Now, what we're talking about today is what happens when you have an x inside the log. And we're still going to do this by flipping the log relationship. And it's 3 to the 2 is x plus 7. And all of a sudden, this becomes extremely solvable because that's 9. We should simplify that first, equals x plus 7, and then 2 equals x. And if you check, then we would be saying log base 3 of 9, right? In here would be 9, and that is 2, of course. So we, in order to solve and not just guess, we also flipped the log relationship, simplified the exponent on the left, and then solved for x. They could get a bit more complicated if the exponent doing isn't as easy. There needs to be a verb, like multiplying, the exponentifying, I guess. But if we had log base 16 of 2x plus 1 equals negative 3/4. When we flip the log relationship and get 16 to the power of negative 3/4 equals 2x plus 1. Hopefully we are comfortable enough with negative exponents now to realize this is 1 over 16 to the 3/4. That is, well, the 4th root of 16 cubed. Hopefully we should know about splitting that up. And I'm not going to write this down because I'm running out of space fully, but right, we can say it's like 16 to the 1/4, which is a fourth root of 16, all cubed. Fourth root of 16 conveniently happens to be 2, and then 2 to the power of 3 is 8. So we get 1/8 equals 2x plus 1, and then we would finish solving that. Sorry that I ran out of paper, or electronic paper, but I think people could figure that out. So even when the doing of the exponent over here, as opposed to the 3 squared, is more complicated, you just take your time, and eventually you'll be able to solve for x also. And here's this if you want to look at it again too. All right, what we would have now is sometimes we need to isolate the log. As in, what if I don't write the log relationship only works if all I have on that left side of the equal sign is the log. So similar to radical equations when you could only square both sides if the radical was isolated, here we can only flip the log relationship if the log is isolated. So I would start by subtracting 3 and get 4 times log base 4 of 3x plus 5 equals 2. And then I would divide by 4 and be left with log base 4 of 3x plus 5 equals 2/4, which is a half. Now I can flip the log relationship and get 4 to the 1/2 equals 3x plus 5. This one is actually going to work out kind of nicely because 4 to the 1/2 is root 4, which is 2. 2 equals 3x plus 5. And then we would finish that. I don't think people want to watch more video where I just solve that. But if you do, good for you. Let's do one trickier one where what's inside the log contains an x squared. And if we think about this, it might look worse, but it's really not going to be worse. We can still, this log is already isolated. So let's apply the log relationship. And we'll have 2 to the 2 equals x squared minus 3x. Or 4 equals x squared minus 3x. If I subtract 4 from each side, I would get 0 equals x squared minus 3x minus 4. And now it's just another type of solving after we've gotten rid of the log. We're going to factor in ZPP this, x minus 4, x plus 1, x equals 4, and x equaling -1 would be the two options. And both of those will work. Yeah, so always remember, isolate the log, flip the log relationship, work slowly through the exponent doing if you have to. Those are the key things to remember for this lesson. Now I have to go to my STEM day basketball activity.